This is a production of Cornell University.
So today we're going to talk about breeding selection evaluation for cold climate conditions. You're going to learn about what is all happening at North Dakota State University. Most people don't realize what we're actually doing there in a state that doesn't have trees. So back in 2017, I gave a similar talk to the Magnolia Society in Sweden, and there was people there from Norway, from Sweden, from Finland. They were all talking about how horrible their climate was. So I quickly changed my title to "My Climate is Worse Than Yours." And that was the theme at that conference. But so this was back in January 2019. So we had a -13 temp. This was 2 weeks before the polar vortex hit. So this is a pretty average day in January for us. You can see how happy I am with that. Our program started back in 1954. It's a really long lasting program. It was started by the gentleman there in the middle, Dale Herman. And he is emeritus, so I took over for his position when he retired in 2010. I started in 2011. You're going to see some pictures of our research farm in here in just a moment, but we actually did name and dedicate a majority of the arboretum in his name. And this is the only time I can ever think of where somebody hasn't given $1 million or died. He gave no money and he's still alive. But we did name the arboretum after him. Because of the amount of work that had went into it, and it has given me the chance to stand on his shoulders, which you'll see in just a moment. The main purpose of our program is diversity. We know the issues with ash, with elm, spruce, pine, all of the disease and insect issues that we're having. We need to increase diversity, and that's what our program is all about. We need well-adapted, winter-hardy, pest-resistant trees for the northern climate. I always tell people I'm the northern trial for the US, but I'm also the southern trial for Canada. Canada has gotten rid of a lot of their kind of USDA components, so all of the research now is being done in the industry. And so it's kind of unfortunate. So we have a really strong hold in Canada. Our material goes up there quite a bit. A lot of the commercial nursery cultivars are not suited for a zone 3 and a zone 4, so we really have to come up with new material. Two main goals of the program. One is to evaluate unreleased materials. So everything that's out there, we work with the nurseries. When you read the tag and it says it's zone 4 hardy, it's generally because it's gone through our program. And so we give the thumbs up, thumbs down on the materials. And then the other goal is to actually select and breed new material for the nursery trade. As Brandon said, we have 58 releases that have gone into the nursery trade. Not all of them are viable, but quite a few are. And what's nice is that, yes, we are cold, but they have a wider use than just a zone 3 and a zone 4. So where am I? North Dakota is probably one of the 2 states that people normally have never visited. And so that's what it comes to, North Dakota and South Dakota. So here's our great big world that we live in. So we'll zoom in. There's me. And so if you ever want to come out and visit, don't visit in the winter time. Come out in the summer. It's quite beautiful. But we're sitting on Fargo. This is what we're kind of known for, is the movie Fargo, even though it was not filmed in Fargo. But if you do visit Fargo at the visitor center, we actually have the original wood chipper from the movie. That's our claim to fame. Anyway, so here's our state, and so our evaluation sites. Fargo, you can see, is on the far right side. I can actually throw a stone into Minnesota. We're right on the Red River, and the Red River Valley is an ancient glaciated lake. It was one of the largest Great Lakes, larger than all the Great Lakes combined, and one day it also decided to drain away. Our topsoil ranges from about 50 to 100 feet deep, but it's a heavy clay. And the rest of the state then is a sandy loam soil, and so that's why we came up with the Absaraka site, because this is actually on the beach edge. I can dig down 5 feet and hit gravel. And so we'll talk a little bit more about that. But across the state, we have these other red sites. These are other sites that we're doing evaluations at. One that I'm actually really excited about is this Langdon site, because it's a true zone 3B. And the only issue I have to worry about is not deer, but moose. They'll actually come in and eat the young trees. Now we had an anomaly. We had the coldest winter we've had in the last 25 years was this past winter. So the traditional map that we see is here on the left. So the upper part of North Dakota is a zone 3, 3B. The rest of North Dakota is primarily a 4A. We actually hit primarily a zone 3 and 3A, even parts of zone 2. And so it was a really brutal winter. We're located on the 47-degree north latitude, and this will come into play in just a moment of where and how we select our materials. That's a really important aspect, because I use the Köppen-Geiger climate classification system. And so we're in a DFB, and that means we have a warm summer, humid continental climate, coldest month average below 0 degrees Celsius, all months with average temperatures below 22 degrees C, and at least 4 months averaging above 10 degrees C, and no significant precipitation difference between seasons. And so that plays then into our world zones. We match up our DFB to other areas. One area where we get a lot of material from is Harbin, China. Harbin, China is almost a complete match to Fargo, North Dakota, or North Dakota. When I first started at NDSU, my predecessor, Dale Herman, was still around, and he came up to my office. First week I was there, and he goes, Todd, there's one thing I never did when I was working here at NDSU. I said, Dale, what's that? He goes, go to Siberia to select plants. And I said, I quit. I'm like, are you serious? But it matches, obviously, our zonal climate. So if the plants do well there, they're going to do well for us. So just to give you an idea, obviously way too much here, but if we look at the bottom here, last frost-free date is May 10th. First frost-free day is September 25th. We usually are much earlier than that. Our average growing days are 130. So it's a very, very short season. Here, our average temperature generally is -17 in January. January 29th, or 2019, we got down to -36. And that's the actual real temp. And it was an extended length of time. It wasn't just like one day. And our Langdon station actually fared a little bit better. They got down to -38. I say better because I'm one of the few people in the United States that wishes for a true -40 temp, because it really screens out my material. I want to see what's going to be super hardy. So the Arboretum itself, as we saw, is located in Absaraka, North Dakota. And we have evaluated over 200 different genera, over 3,000 different species and or cultivars, and over 9,000 accessions have come through the system. Obviously, not all of them are alive. My job is to kill plants. So we do not have that extensive of a collection, but we do. It is the largest woody plant ornamental collection in all of North Dakota, but even the Northern Great Plains. We only rival the Minnesota Landscape Arboretum, but we don't do weddings. We have a total of 80 acres. About 60 of that is in my control. So if you Google Absaraka, North Dakota, this is what you'll get. So here you can see Fargo. Fargo is actually a fairly large-sized community now. Fargo Moorhead's about 200,000 people. People don't think about that, but that's about a third of the population of North Dakota. And then here, this red pin, that is our research station. So it's outside of the Red River Valley. If you go in, you can see our little island of green among the sea of agronomy. And then if you would come in, this is what you would first see as you come inside. So we have a lot of display gardens and a lot of plant trials. So this is an aerial view. The center is the Daley Herman Research Arboretum, about 35 to 40 acres. And everything's planted in true arboretum fashion. So it's just random and it's all alphabetical. And it starts with ABs, goes all the way to Zelkova. Zelkova is not hardy, but I plant one every year, so I have A to Z. So I have an annual Zelkova. And because, of course, everybody plants alphabetically, right? Yes, of course. The other areas are where we do our plant trials, which you'll see here in just a moment, where we line material out, whether it's a germplasm that we've collected or it's material that we're testing for a nursery for a trial. But again, about 55 to 60 acres is what we control out of the whole farm. There is the horticultural farm is the whole thing. So we do have hops growing out here. So there's hops back, I think back here now. There's grapes. which have gone quite a bit. This area is now certified organic. So there's a lot of other things going on with this farm as well. But for the most part, I control the whole farm for the most part. The nice thing about our woody plant improvement program is that it is obviously ideal for the northern climate conditions, but it also matches really well for the urban site as well. Because we know that urban soils are typically compacted, they're dry, they're high pH. North Dakota is one of the driest states. We're the 8th driest in the nation. And so a majority of what then we screen for is drought tolerant. We also screen for pH tolerance because our soil at the research farm ranges from about an 8 to an 8.2. And that's typical for most North Dakota soils, is that we're greater than 8. So some evaluations that we do, germplasm source-wise, you know, we're getting material from foreign and domestic seed sources. We go on exploration trips within the region, within the nation. We do some exchanges internationally as well. That gets more and more difficult every year. But we also work with some of the exchanges that happen, like with Longwood and the Atlanta Botanic Garden. And we're working with these larger entities that have ways into some of these countries. We are looking at plant breeding. I'm going to talk a little bit about plant breeding today. That was one thing that my predecessor, Dale Herman, was not able to do in the time frame because he had to collect all this material. That farm that you saw used to be a wheat farm, and there was nothing there when he first started. The first planting was in 1974, and so he had to wait for everything to mature. So he was doing seedling selections, no breeding improvement. My background is in vitro tissue culture. I worked under John Priest for my master's and PhD with woody tissue culture. And so we look at somal clonal variation, embryo rescue, mutagenesis, and also some genetic engineering. We work with nursery partners, Bailey's, Isley, J. Frank Schmidt, JN Plant Selection, Spring Meadow. I mean, all the major nurseries in the US and Canada as well. We're working very closely with them. Isley came out with a Jack Frost series of hybrid Korean and Japanese maple. So we tested them out twice for them. Not hardy, which was good, and we'll talk about in a minute. But here they have Ice Dragon and Arctic Jade. Northwind lasted for a while, but it eventually died for us as well. This is Northwind. You can see the sun scald damage and the dieback. This tree is completely dead now. So this, again, what we do is we kill plants. This was one I wanted to try the Arctic Jade into my yard to give it a little bit more protection. So this is here on the left. This is actually spring. It's dead, except for the very base. So I thought, hey, I can turn it into a bonsai plant. And it's a beautiful bonsai now. So if you want a good bonsai, Jack Frost series. But we work very closely again with industry partners. We have a big industry block that we are planting out. You know, we get the JFS trial pack that they send out everywhere. Again, we kill all their plants. But we work, again, very closely with a lot of the different nurseries. Plant improvement methods that we're involved in is breeding, seed source and seed lot variation, and then selections by, obviously, landscape observations, where most of your cultivars come from when it comes to woody plants, is just finding that something unique that's already growing out there. So some traditional breeding. I got really into magnolias, and we'll talk a little bit about magnolias here in a minute. You wouldn't think that we could do magnolias in North Dakota, but we can. And so here I'm playing bumblebee. So our primary breeding that we're working with is elm, lilac, magnolia, and maple. We're dabbling in some other areas as well, but that's the primary ones, and we'll talk about why. So maple-wise, again, this is where I'm standing on the shoulders of Dale Herman. And so he has selected all of these material that's super hardy. And then we can now take it to the next level. So here we have Northern Spotlight Korean maple, by far the hardiest of the Korean maples, because even the seedling selections that you get from Bailey's are very marginal. They die back extensively for us. This is hardy down to -40. One of the problems, though, with the Korean maple is there's not much variety. They're beautiful, beautiful fall color, but you don't have any variety. There's no cut leaves. There's no red leaf forms. You know, there's none of that variety that you see in Japanese maple. And that's where Isley got into the idea of doing the hybridizing with palmatum and pseudocibolianum. Here, then we're doing the same because now we use our parent, which is hardy, the hardiest, and cross it. So we did some initial crosses, and this is what we were getting. So a lot of variety with even purple leaf forms, green leaf forms, red forms, cut leaf, you name it. A ton of variation present with these crosses. This is one of my favorites. Comes out with this beautiful red. It does fade into a darker green, but then gets an amazing red fall color as well. So these now we're testing for hardiness. I should be showing you some controlled freezer studies, but then also planting them out into the field to kill them. Hopefully these won't die. We obviously have soil-induced chlorosis. That's very typical with high pH. So I teach our woody plant identification course. These are our golden maples. So any of the Freeman maples don't do well for us. One is because of hardiness issues, especially like with autumn blaze, but also obviously with the background of the red, and even the silver are not hardy for us and not pH tolerant. Silver maple here on the left, you would think that, wow, we actually can kill a silver maple. Yes, we can kill silver maple in our soils. So this is actually a tree that's close to our main plant science building that no longer is there, the one on the left. And then also red maple, again, showing extreme iron chlorosis. And for some reason, every time we build a new building at NDSU, the architect always puts in a red maple, which I'm really excited because then allows me to teach red maple for about 5 years. And then it will die, but then they usually plant a new one. So we've had some ongoing ones. So it's nice. Obviously, the hardiness issues, this was just a study that was done with autumn blaze in Sienna Glen, showing that DBH had a really important factor on dieback, but they just don't do well for us. With our screening, though, is that we have found silver and reds that do well. And so now I can take this and we are making our own Freeman maples. So with the silver maple, Blair, McCade seedless, silver cloud, Skinner eye, BB, wary eye do very well. pH tolerant, really hardy. Same thing with rubrum, autumn spire, fall grandeur. Fall grandeur is an NDSU release, as you can see here on the right. Nice upright form to it. The issue that comes in is that nobody is producing this red maple, which is hardy to a zone 3B and pH tolerant to 8.2. But nobody's producing it because in order for a nursery to produce a new cultivar, they have to drop something. And if you look at like J. Frank Schmidt, who they're the ones that are known for producing the shade trees, they already have 25 of their own red maples. So with that said then, is that we are going out and using this introduction, and we're breeding with it with the silver maples to make our own Freeman maples. And so here we have our seedlings. We work with several different nurseries because again, we're limited with some space. We have some conservation nurseries in North Dakota and South Dakota that we work with. So we line them out, then we go through and we can select what we want, and then they sell the rest as conservation plants. So it's a win-win for both of us. So then we end up with these really nice hardy Freeman maples that are doing well. We're seeing obviously a lot of variation with the hardiness and with color, but we're again selecting on our site with that high pH soil. Here we have a bicolor that's doing very well. And again, this is just seed source. So this is what Dr. Herman was doing, was selecting more just seed source variation. Redbud, you wouldn't think that redbud would do well in North Dakota, but again, through seed source evaluation, we have a source from Kansas that would die back to the snow line every year. Not too much of a surprise. But then we have a Minnesota source that does exceptionally well. And so this past year, J. Frank Schmidt released it, Northern Herald Redbud. Beautiful redbud, but still only hardy to a 4B. We have another strain that's actually hardier to probably even a 3B. Actually, I know it's hardy to 3B, but the leaf quality isn't as nice. But we're going to use it as a parent and actually breed with red buds. We have an agreement right now with Bailey's because Bailey's bought Mike Durr's breeding program. And they're actually using our red bud, the Northern Herald, to increase the hardiness of a lot of his material. But we decided that we're going to do it as well. Again, by landscape observations, again, letting the seedling variation of the city foresters, they've done a great job of getting a lot of seedling material. So we actually drive around towns. That's what you do. You drive around towns looking for something different, upright Baroque. We're really trying to get more uprights into the boulevards, so there's less pruning, healthier for the tree, more cost effective for the city as well. So always just looking for something that is just different, but letting nature do its thing. Here's one that is amazing, September Flare Sugar Maple. This is one of our releases. Hopefully Canada is going to be getting more excited about this, but it's day length dependent, not temperature dependent on fall color. For us in North Dakota, it starts coloring September 15th, whether we have an early fall or a late fall. And so what's nice is that we're always looking for material that shuts down early. That's so important. That is a good indicator that it's going to be hardy if it shuts down early. One of the big issues with a lot of the cultivars that are out there, they're from a southern source. They just keep growing and growing and growing and growing. They never shut down. And that's very detrimental for us. So this shuts down, it starts coloring. If you look in the background in this picture, nothing else in the landscape is coloring. And this sugar maple always colors in the middle of September. And what's nice, pH tolerant to an 8. So how long does it take to release a tree? I've got this September flare. It's like, oh, I want one. I'm going to get one. The Morton Arboretum put out with their Chicagoland Grows introduction this nice kind of idea of how long does it take. And so they release Exclamation London Plain Tree. And so it gives you an idea is that the time frame that we're looking at is about 15 to 50 years for a plant to actually be available in the nursery trade. Because we spend all the time doing the selection work, but then we're also going to be doing propagation. We figure then we make the selection, and then it has to go to the nursery. Then the nursery also then wants to evaluate it in their production system for X number of years to make sure it's going to work, whether it's going to go container, whether it's going to go bare root, is it going to be in the field, what are they going to do? And so it really can take a long time. This is one of the biggest problems that we have, is that we're dealing with multiple generations. We know juvenility periods in woody plants can be anywhere from 5 to 15 years. So if we're doing breeding work, I'm doing a lot of breeding work that won't be for me, but it'll be for my successor. So here we have that London Plain Tree, liner grower if you're out in the Pacific Northwest. Year 1, either tissue culture or cutting. Year 2, outdoor liner bed, then line out the field, establish central leader, root prune, develop branching. So, they're evaluating the plants themselves for at least 5 years before they say yes or no. And then a lot of times it comes out to be a no, because it just doesn't work in their production system. Here, nursery production for small to mid-size trees can take upwards to 9 years for them to really see what type of structure is it working for them. For large trees, it can be upwards to 15 years just in the production evaluations. So some recent selections that we have, September Flare is one of our new ones, Japanese tree lilac. This is not utility friendly, but that's good. We want it sometimes non-utility friendly. Compare it to ivory silk, which comes out to be about 20 foot tall. Ours is 35 foot. It's a nice upright. We all know kind of what a Japanese tree lilac can do. They're extremely tolerant. And so this is one that I would want on the boulevard. You can see obviously with ivory silk, it is in a utility friendly situation, and that's good. But I don't want this little blob on my boulevard if I don't have utilities, because in South Fargo, our utilities are underground. I want summer flare. And what's nice is that you can actually watch it grow. And again, that's important for nursery releases, is that they have to be able to kick out a tree within 2 years, or it's not profitable for them. They always keep talking about how we want these dwarf compact trees, but then they won't grow them because they take too long. This is one I'm really excited about. We mentioned that it takes 15 to 50 years to release a plant. This is our Northern Empress Japanese elm. And so it has inherent DED resistance because of being a Japanese elm. It's straight Japanese. And we sent this out to Carlton, which is now owned by Bailey's. They wanted to test it because Frontier elm for them did not bear root well, and they were looking for a replacement. And so they tried out our new elm. It's much smaller stature, about 28 foot. So not a huge elm by any means, which is great. Fits into the landscape really well. And pH adaptable, grow into any type of soil and any type of pH. And what's great is also it's seedless. So we've not seen any seed on this at all. But it gets burgundy fall color. and not very common for an elm to get burgundy fall color, especially one that's hardy into a zone 3. Frontier gets burgundy, but it's not hardy for us. And so through Carlton evaluation, it took them 5 years, and it went through all the production evaluations with glowing thumbs up, and they're actually replacing this with Northern Empress with their, for their Frontier. So very excited. This is kind of our Cinderella story. So this is actually available next year. Super excited. But the original germplasm was planted in 1984. And we just released it in, I think, 2012. So I do a lot of tissue culture. So we were getting it into tissue culture. You can see how much callus. Elms typically will throw a lot of callus. And so I don't want to go into great detail with some of the studies, but we wanted to use an antioxidant compound, PCIB, the p-chlorophenoxyisobutyric acid, which is a kind of an antioxidant or antioxidant compound. And what it does is that it actually binds to the site of the auxin receptor, so it won't produce all the callus. And so we did a salt screening as well as using the PCIB. And we were then culturing it after 6 weeks. We kind of wanted to see what would happen. And we found that 10 micromolar of the PCIB significantly reduced the amount of callusing, and it gave us a really high propagule number. So we're very excited about that. But the neat added bonus, what I really wanted to say here, is that we were able to cross borders into Canada with it. There's quite a few provinces in Canada that's DED free, and the only way I can get a plant into them then is through tissue culture. And I had a fight with the Canadian government to really get them to accept cultures to go across that border, but in the end I won. And so now we have a tissue culture facility, agroforest in Canada, that is actually producing liners of this as well. This is cinnamon curls dwarf Korean birch. It's a costata birch. It's not a very well-known birch. It's a Korean birch. My predecessor, he loved big trees. And when I first came on site and started learning our germplasm, I was like, wow, I really like this tree because it's dwarf. And he's like, Todd, I don't know why you like dwarf trees. I'm like, because the rest of the world does. But anyway, so here's me standing by it. It tops out about 9 foot. Well, I've got another picture here in a moment, but now Isley Nursery has it in cuttings. Here you can see on the right, those are rooted cuttings in the summer of 2019. In 2018, they were able to get tissue culture liners and get them to be about 2 foot in 1 year. So very excited. Hopefully they're going to do very well because they have a beautiful exfoliating bark. For us, Fox Valley, the Little King river birch just doesn't perform. It gets chlorotic, it's not hardy. This is a great replacement. It's drought tolerant, it's pH tolerant as well. Beautiful, beautiful selection. And what's nice, you can't really see well in here, but it's already starting even within that first year, getting the exfoliating bark. Lava burst buckeye, I always say this is a buckeye that you've turned on its side. Buckeyes typically get very wide, but I'm really trying to push more uprights to get a better fit into a boulevard. So this is an upright buckeye. No problem with leaf scorch. Beautiful fall color. It actually produces very little seed. I wish it produced no seed, but it produces very little seed, and they're generally quite small. But look at the structure of that, all upright, just beautiful, beautiful tree. This is what it looks like after a second year planting. This is the first year planting. This is my technician's wife. He says, the height of it is the average size wife. But anyway, but what's nice about this is that it bundles well, it digs well, you don't get limb breakage. And again, those are the things you have to consider when you're evaluating something, because how is it going to come out of the nursery as well? This is one of our newest one, a Tiantian birch. Again, not a very common one. Birch is very strong for us. We have Dakota Pinnacle birch, but that actually can get borer as well. This one's actually an improvement of Dakota Pinnacle. Extremely drought tolerant, beautiful form, beautiful high quality foliage. And again, we have it in tissue culture and ready to go for release. We also have an azalea that we screen for pH tolerance. The University of Minnesota has the Northern Lights series. They're hardy, marginal for us, but not pH tolerant. So here we have this beautiful fire flare orange that does extremely well with our high pH and our heavy soils as well. So we have that in tissue culture, and hopefully we'll be getting that out here soon. Some future releases, Cercidophyllum japonicum, Katsura tree. Very excited about this one because this is marginal in the Twin Cities. And this is hardy to zone 3B. Acer truncatum hybrids. This is a big hybrid now, the truncatum with platanoides. JFS has come out with all of these different ones. They're not hardy. They've all died for us. But we actually had truncatum next to some of our platanoides that we got from Norway. Extremely hardy. We weren't ever going to plan to release a Norway maple, but then we found the diversity within these. So all these nice, beautiful fall colors. And so far, they've been hardy all the way down to -36. This is one I'm really excited about. Standard leaf of these hybrids are here on the left. This has this miniature little crinkle leaf. And so it has a really neat ornamental quality to it, kind of like a little bit of like a crispy lettuce look. But the new growth comes out like this. So all of that new growth every year would be that bright red, crinkly look. So super excited about that. We also have a purple leaf form as well, and ends up kind of that purple red in the fall color. So some research, obviously I already mentioned tissue culture. We do a lot of tissue culture. We do a lot of grafting. Here we actually messed up some oaks. So we've done a lot of oak rootstock compatibility trials. We took Prairie Pioneer dwarf chinkapin oak, which is actually pH tolerant, and we put it on bicolor, which is not, on the left, and guess what? It becomes chlorotic. We put it on macrocarpa on the right, and no problem. So it shows that really that rootstock is so important when it comes to pH tolerance. And we cannot grow white oak, but we put white oak on macrocarpa, and it does beautifully for us. So we actually get a nice fall coloring oak. A lot of cutting propagation, Acer triflorum. This is one that's impossible to propagate. We have a release called Orange Aglow. We have about 5 in the accession. So I took one of the sibs and I cut it down to the ground so that way I can rejuvenate, get the new shoots, and do some etiolation. And we're actually getting some roots on triflorum. So really excited about that. Then hopefully we can actually start getting clonal triflorum. Magnolias, oh my goodness, that's a whole nother talk, and we've got 15 minutes, but I just kind of want to go through that because, again, most people don't realize that we can do magnolias, and it is one of our big breeding programs. We do a lot of shoot forcing to get things into tissue culture. So I'm just introducing magnolia into culture. We do a lot of freeze tests. We have the programmable freezers, and it just gives us a better controlled environment. And so here we were looking at saucer magnolia, and then again, this is where I stand on the shoulders of Dale. He released a magnolia spring welcome. Spring welcome magnolia is hardy down to about -38. We lost some flowers this year, so we were kind of on that marginal end. But here you can see, which is not too surprising, that we had 60% damage at -36 of the flower buds with saucer magnolia. That makes sense. Whereas our spring welcome, we were right around about that 15 to 18% flower bud damage. So really showing that the freeze trials can work for us to do some initial screening of hardiness. So how did I get into this crazy world of magnolias? Actually with Green Bay Botanic Garden, there is a hybridizer there. This is actually his house that I mapped out. But Dennis Ledvina right here is one of the leading, and unfortunately he passed away quite a few years ago now. But he really got into pushing magnolias up into the zone 5. And so I'm utilizing his material, crossing it with what we have, and pushing up even further. Now, one thing for those of you that are grad students and interested in breeding, be careful. Because you can get really involved and really excited about something. So the very first year I did it, I made 150 crosses. And then I did 200 crosses the next year. And that equated to about like 5,000 seedlings. It's too much. And then I had this aha moment one year. I was actually sitting next to, on the plane, to another board member of the Magnolia Society International. He said, "Todd, what are you doing with breeding?" I said, "I don't know. I'm like crossing everything." He goes, "That's dumb." He goes, "You already have a hardy white. All you need is a hardy pink and a hardy yellow." He goes, "Why spend all this time crossing everything?" So you really do need to be focused and look at that. So that was kind of my aha moment. So this again is just showing all the seeds. You can see where we were making all these crazy crosses. But ultimately what I'm focusing on is hardiness. looking at overall plant size, looking for some dwarf compacts, flower color shape, because all we have hardy for us are white. And that's why I want to increase the colors and get better forms. This is our spring welcome magnolia. It's a Lobneri cross between Cobus and Stellata. Does really, really well. We've done quite a bit of varietal trials. Here's Yellow Lantern. This looks beautiful. I actually had to borrow a picture from the Missouri Botanic Garden for a flower because it only flowers for us below snow line. And here in the next picture, you can see also where its stem dies back like pretty much every year. We do get flower buds, but they never make it through the winter. Even Leonard Messel, you can see where the flowers are, is below snow line. Royal Star, which is kind of the standard, is only flowering below snow line. So you can see here some flowers and some flowers. So there's a lot of room for improvement. So how do we overcome bud hardiness? Again, is utilizing our material and then focusing on these acuminata hybrids, because the acuminata is really, really hardy. And it has those yellows, but also the hybrids that Dennis Ledvina did, has the reds as well. So we found another one that's straight stellata in Bismarck, North Dakota, that's survived down to -42. So this is one that's not released into the trade. So this is my own private breeding parent. Just beautiful magnolia, but again, just straight white. This is my Subaru that we actually filled with all these plants from the Green Bay Botanic Garden and took back to North Dakota, planted them out. Most of them died. So here's my students that were planting them all out. They look beautiful, you know, in the summertime. Unfortunately, you know, a lot of things have died. So again, this is kind of beyond, but you know, cotton candy, beautiful plant. But we really wanted to show that our breeding efforts were worth it. It finally died in 2017. Rosemarie died in 2017. This is one of the most beautiful hybrid magnolias out there. Cylindrica, completely dead. Angelica is dying. Here's the flower buds, obviously not worth it. That's the whole power of a magnolia. Red Baron has actually shown to be hardy, but no flower buds have formed. Genie is one of the best because it's compact. You get this amazing flower color, but it's not hardy, which is good. But we're actually using Genie to breed with to get a really nice magenta color. These are all of our 2018s that have died. Here's ones that are alive. Actually, 2019 now, pretty much all of these are dead except for Red Baron. Looking at the different bloom times, extending, really focusing again on the acuminata hybrids. Again, like I said, this is much more in depth than really what we need. But again, focusing on these smaller forms too. Sunsprite is amazing. It's about 12 foot by 1 foot. And this is the yellow that I'm hoping to get hardy, because this would just fit in the landscape so beautifully. So if you ever want to get into magnolia breeding, it's actually really easy. It's one of the most easy plants to breed with because all of the parts are so readily accessible. The stamens are there, the carpels are there. We do have obviously tepals. With the female portion, it's receptive when all the styles are curling out. When they curl back up, they're no longer receptive. And at that point, then the pollen will dehisce. So you can remove all of the stamens and then process your pollen. And you can do this even on the same plant because you'll have some that are receptive, some that are no longer receptive. And so you can collect pollen pretty much at any time. Here I've got the stamens that you pull off. So you can see here, this is our female portion now that's no longer receptive. Stamens have all been removed. You put it on a piece of paper, let it sit out overnight. They dehisce, they release all the pollen, and you're good to go. So whenever I go collect pollen, this is my hotel room. I always have to put the do not disturb sign on because I figure they think that I'm like Breaking Bad. Like, I don't know what I'm doing in there. So I don't want people to come into my room. But again, same thing here now is that we're using this Genie pollen that we collect and then cross it into what we have. Now we did a lot of field breeding. This is actually my son, my youngest son. He is one of the best hybridizers. Everything he hybridizes always works. But one of the big problems is that cold temps in the spring limits pollen tube development. And so field breeding is really difficult. And so again, here we are out in the field. It's also more dangerous. The older I get, the less I want to go up on a ladder. So I send my son up there. But again, using our spring welcome magnolia, we do a lot of crossing. But then what happened, so here's a great example. April 26, 2017, we got down to -4. And here's our magnolias in full bloom. And we got down to -4. There's no pollen tubes developing then. And so we've now gone into breeding everything indoors. So I've got everything potted, we force flowers, we collect pollen, etc. So everything I do is inside. And my grad student on the left, my son again here on the right, I let him do all the work because he's amazing. Always looking then to get that fruit to develop. Then we collect all the seed. We actually go out and collect acuminata seed for all of our rootstocks. So again, get my son out there to collect the seeds for me. Then we process them, grow them all out into nice plugs to create rootstocks. We do a lot of grafting as well to get everything scaled up and number-wise. Here's one that was exciting. This is actually not with one of our hardy ones, but I'm hoping in the future be able to cross it in. It's a variegated First Love by Red Baron. Just a beautiful, beautiful plant. Now, phenotyping. This is one thing I discovered several years ago. It's like phenotyping is always difficult. And how do we deal with it? You know, I know a lot of you have had to deal with the color charts, and they're very subjective. You know, what I consider to be a red, somebody else might not consider to be the same red. And so several years ago at ASHS, I was actually thinking it might be from somebody from Cornell that was doing it. It was in a fruit breeding where they were actually evaluating apple skins for the color. And colorimeter is expensive, but not very subjective. And so you know, most people use the CR400, but it's very expensive. And so what I found and what they were presenting at ASHS is that they were using the NYX Pro color sensor, $150. And it links up to your smartphone, and you can actually scan then the colors. Now, the NYX Pro is designed for interior designers, so they have all the palettes for paints. So all of the Sherman-Williams and everything. So you can set it on anything in this room, and it will tell you what Sherman paint will match that color. So what we did then is use the NYX Pro, and we had developed our own database. And it tells you how to do that. And so here I'm phenotyping Magnolia Teeple, and it will scan the color. It'll tell me all my RGB, everything that I need to know. But then using the RHS color palette, it will actually tell me what is the closest matches. And what I find is that I take an average reading, you know, 3 to 5 different readings in an area, and it's almost always the same. And when I go back then to the color palette and I match it up, I'm like, yeah, that's exactly what I would have chose. So it really cuts down on time. It cuts down on the subjectivity of trying to find those colors. But this is what you have to do. I had an undergrad scan all 812 palettes to create the database. But then once it's in, then it works. We do a little bit of genetic engineering, not a lot. Obviously, ornamentals, we can't do release a GMO into the landscape. But one of the big problems is that the juvenility phase with woody plants. How do we overcome that? Well, we can do serial grafting to get them to flower sooner. And so one thing I found is that the fast track breeding that was used by the USDA with plums, we can actually utilize that in ornamentals. And what that is, and again, that's a whole nother talk. If you're not familiar with fast track breeding, highly recommend you look it up. But what they did is they inserted a early continually flowering gene into plum, and it turns the tree into a vine. And it then sequentially flowers all along the nodes. So you'll have fruit development at the base, and it'll still be flowering at the tip. And so it constantly flowers, and it flowers within the first year. So it allows you to do some breeding. Now for me, and then you can do back crossing to remove that, but then again, you're still stuck in that generation of the back cross. What we're utilizing it for and want to is to create rootstocks that have this early continually flowering, because they show that in apple, they can have these ECF transgenic rootstocks. They put a sign onto it, and that sign will flower in the first year. So that's translocated, not obviously the gene, but the characteristics. So if we can do that with Magnolia, I don't have to wait, because our spring welcome Magnolia from seed to flower was 13 years. I can't wait that long. But if I can then develop these seedlings and then graft them onto these transgenic rootstocks, I can screen them within the first year for flower color. Yes. Oh, okay. So what we saw is that we actually are getting somatic embryos directly forming using Piclorum. So very excited. So I just want to end on this. I know I'm out of time. But what is the hardest part of woody plant improvement? And the easy part is obtaining germplasm, propagating cuttings, planting, evaluating, breeding, and selecting. That's the easy part. The hard part is naming your release. How do you come up with a name? And I go into the whole royalties and et cetera. But we've got this new plant, and this is where I'll end. Is Emerald Beacon, that Tiantian birch. I wanted to name it Emerald Beacon, but I couldn't because of Michael Durr owning Beacon Oak. He owns the term beacon, so I couldn't use it. So we had to change it to Emerald Flare. So anyway, so with that, in the end, all we want is happy trees, right? We do have quite a bit of information online. If you ever want to get more, contact me. Just let me know. With that, we'll take any questions.
Any questions for Dr. West?
Yeah.
I don't know if it has practical application to your program, but what do you know about the anatomical or physiological basis for this extreme cold hardiness?
Good question. And one of the things that we look for is that early shutdown, because that's a big indicator of extreme hardiness. Certain species have the ability to work with hardiness, like cornus, obviously. But with a lot of the species, we're just looking for that early shutdown. And that really is a big indicator for us for the cold hardiness. Yeah.
Oh, that's your mechanism question. The azalea, you should buy that one fairly
I
quickly.
did,
But
yes.
Any idea on how it tolerates that high pH?
No, I don't know. Yeah, but it's doing exceptionally well in that high of a pH. And it always has, because it's been under evaluation since 1974. Wow. And it's always performed beautifully. So we finally got around to releasing it. But yeah, it handles that high pH. Why?
Yeah.
Because it really shouldn't. And again, that's that seedling variation. Just for some reason, that one's doing well, because the others did not. We've evaluated a lot of azaleas for hardiness and for pH. And this is the only one that's doing well.
I saw a few crabapple trees in lots of pictures. Do you do crabapples?
I do not. We do crabapple evaluations, but I don't do any improvement work with crabapple. No, that's a hard world to get into. There's so much out there and so many people that are way ahead of us. Yeah.
We get some azalea, that high pH azalea?
Yes, once I get it available, yes, I will send you some.
Yeah.
Yeah, once we get the cultures going and we root them all out, yeah, I'll definitely
I
get you
did some work on that before, but it was a losing battle. I mean, there weren't any that I tested that were really high pH. Yeah.
Oh yeah, it's a total losing battle. But this one's amazing.
Yeah. Very
Thank you so much for your time.
This has been a production of Cornell University, on the web at cornell.edu.